Hi, Integrated Math 1. Welcome to lesson 5.1.3. This is a really short unit. We've kind of flown through this. We are doing constructions again. In this case, we're going to be constructing an equilateral triangle, theoretically, eventually, maybe. But that means you need your construction tools. So you need a compass, you need a straight edge. Make sure you have these things before you get the party started. So if you have your things, you got your book, we're on page M5-33. Just a quick rundown on what to expect today. This is the big one. We're going to use our construction tools to bisect an angle. We may or may not get around to constructing an equilateral triangle using a compass and a straight edge. And I don't know that we'll get to constructing an equilateral triangle inscribed in a circle, but maybe. We'll see what happens. So our key terms today, angle bisector. That's the big one. Like I said, that's the big one for today. So you have used construction tools to create a squares. We've done that. You've used your construction tools to create a regular hexagon inscribed in a circle. So how can we take this a step further? I think we can. So in this lesson, we will eventually construct an equilateral triangle, maybe, hopefully. To perform the construction, you are only going to be able to use a compass and a straight edge and just rely on those basic geometric constructions we've already learned, right? We've already learned how to duplicate a line segment. We've already learned how to duplicate an angle. We've already learned these things. So Sophie, here on page 34, Sophie claims that she can construct an equilateral triangle by constructing and then duplicating a line segment 3 times and having the endpoints of all 3 segments intersect. So she's going to make 3 equal lines and she's going to make sure all of the endpoints intersect. Roberto thinks that Sophie's method will not result in an equilateral triangle. Is Sophie correct? Explain why Sophie's reasoning or Roberto's reasoning is incorrect. So is Sophie right? And if she's right, explain why Roberto's incorrect. If she's wrong, explain why Sophie's incorrect. So go ahead, hit pause, jot down your thoughts, hit play to check your work. Well, an equilateral triangle, by definition, has 3 congruent sides. So if I make 3 congruent sides that endpoints all meet up, yeah, I'm going to have an equilateral triangle. So Sophie is correct. Roberta didn't realize that 3 congruent segments can always be connected at their endpoints, and that means it's always going to make an equilateral triangle. It's just how it goes. So let's dig into this whole idea of bisecting an angle. This is the big one. So just as line segments can be bisected, right? That was what started this whole unit. We had a line segment. There's the midpoint. We bisected it. Angles can be bisected too. If a ray is drawn through the vertex of an angle and divides the angle into 2 angles of equal measure, or 2 congruent angles, then this ray that we cut through the middle with is called an angle bisector. The construction used to create an angle bisector is, of course, called bisecting an angle. And does it sound like I just tried to figure out how many times I could say bisect all within a short period? Yeah. So lines and line segments can bisect an angle. Yay. Or ray in this case. So again, one way to do it is using patty paper. We don't have patty paper, but just a real quick explanation. Patty paper is that see-through, square see-through paper. So you can draw an angle on your patty paper using a straight edge. And then, of course, if you fold the patty paper such that the 2 sides of the angle, the 2 rays, if you fold it such that the rays lie on top of each other, then the fold should pass through the vertex of the angle. So if you fold it such that the 2 sides of your angle end up on top of each other, then once open the patty paper, that crease should be your angle bisector. Angela states that as long as the crease goes through the vertex, it's an angle bisector. Is she correct? Why or why not? Hit pause, jot down your thoughts, hit play when you're ready to check your work. She's not correct. Just because the crease goes to the vertex doesn't mean it bisects the angle. To bisect the angle, the crease must divide it into 2 angles of equal measure. It must actually give you 2 congruent angles on either side. So we don't have patty paper, but we do have construction tools. So you can also bisect an angle using a compass and a straight edge. So again, like we've done before, I'll explain what they have here in your book, and then I'll show you with my camera. So first of all, here we have an angle ABC, awesome, or angle C, whatever. First thing we do is we can use our compass to construct an arc that hits both sides. So you need to construct an arc that intersects both sides of the angle, and you can label them A and B. But your pointy guy needs to be on the vertex, and then you swing that arc such that it hits both sides. It must hit both sides. Then we place the compass at A, right? Pointy guy on A, and we construct a little mark out in the middle. And then don't let it slide. You place the compass on B, right? Pointy guy there, and using that same radius, construct another arc. And so when you do that, it creates a little X in the middle. X marks the spot. So you can label the intersection whatever you like. In this case, they labeled the intersection of the two arcs D. And then they just use a straight edge to construct a ray through C and D. And so ray CD bisects angle C. Let me show you what I mean. I'm going to show you what I mean, okay? First of all, I'm going to have an angle here so that I've got something to work with before I even bring the camera up. Haha. There we go. So let me show you what I mean by all of this, my pencil and all that good stuff. So if I bring this up, it's so windy that it's opening my door. That's really creepy. You guys can't see it, but that was awesome. Oh my, the wind is creeping inside my classroom. That's awesome and creepy. So here I have angle C. I'm going to show you how this works. So we said the first thing you need to do is you need to use your vertex C. I'm going to make a point just to make it a little easier on me. And you need to make an arc that hits both sides. So I'm going to make an arc, and I need to make sure it hits both sides. You can label these whatever you like. The book labeled them A and B. You don't have to. You can label them whatever you like. So I've got an arc that hits both sides. And now here's what I'm going to do. You can adjust a little bit if you like. It's up to you. But I am now going to do this on each side. I'm going to put my point on B. I'm just going to make a little mark out in the middle somewhere. And don't let it slide. Don't let it slide. I'm going to come over and do the same thing with A, put my point on A, and I'm just going to make a little mark out in the middle. And look at that. X marks the spot. And you can call that point whatever you like. I think the book was calling it point D, but you can call it whatever you want to call it. And now I'm going to connect. There we go. You just bisected the angle. Oh my gosh, I just bisected the angle to get the point. So you can see that this side is equal to this side, that this angle is congruent to this angle over here. And I just cut my angle in half right down the middle. I just bisected it. Awesome. It's your turn. It's your turn to try one. It's your turn. So there on page 36, number 2, you have angle A. I would like you to bisect angle A. Hit pause, bisect your angle, and then hit play when you're ready to check your work. The wind is picking up outside and it's opening my door. It's creepy. Let's go ahead and bisect this angle. See how you did. I'm sure you did wonderfully with it. So here's angle A. First things first, I'm going to make an arc that hits both sides. Ooh, awesome. And you don't have to label these. If you'd like to, you can, but I'm just going to make some points there. And then we said the next thing is, of course, I want to make a mark out in the middle. So I'm just going to kind of, don't let it slide, don't let it slide. Do that on each side. Don't let it slide. There we go. And I'm gonna connect the dots. Connect the dots. La, la, la. I did not do a good job. Ha! I got a little off. Hopefully you connected better than I did. Look, I didn't even hit A. Oh my goodness. This is not my best angle bisector ever. Sorry. But you get the idea. This isn't bad, right? I kind of like angle bisectors. They're not real hard. They're pretty good. Pretty nice. So now it's time for a challenge. Question number 3. I would like you to construct an angle that is not half, 1/4 the measure of angle H. And give me a little explanation on how you did that. Hit pause, see what you can do, hit play when you're ready to check your work. So here's my thinking. When I bisect an angle, I cut it in half. So if I want 1/4, I have to bisect my angle bisector. Ah, yeah. So, okay, so I got to do this twice then. I can do that. I can do that. So I'm going to come up here. First of all, I'm going to make an arc that hits both sides. Ooh, oh dear. Okay, got it. I made an arc that hits both sides. I want my good pencil. Hey, I'm picky about my pencils. All right. The next step is, of course, I'm going to extend this out a little bit, and because this is kind of a wide angle, so I'm going to kind of extend this out a bit, and I'm just going to make a mark. Don't let it slide. Go to the other side, make another mark, and boom, X marks the spot. So I have now bisected my angle. I'm going to try to do a better job this time than I did last time, because the last one wasn't very good, was it? All right, so I've bisected my angle, but we said we only want 1/4, right? 1/4. So I need to cut this in half. Fortunately, my arc already hits both sides, so I guess I just need to do my mark out in the middle again. I'm going to kind of bring it in. I don't need it so big this time. So make a mark. Don't let it slide. Keep it the same. Make another mark. And my point. And my ruler. And let us hope that I'm more careful this time in connecting my dots. Clearly, some days I do a better job of it than others. Woo, that's a good one. Yeah, look at that. So I had to bisect what I'd already bisected. So I had to actually do my bisector twice, right? I had to do it twice. I had to do it once for the big angle, and then once I did that, I cut this guy in half. And that takes me down to 1/4. Oh, snap. Yeah, so first I bisected angle H, and then I picked one of those sides to bisect. Yay, this is a big fat explanation. You probably don't need all of it. So I'm not going to make you do it, but could you describe how you would construct an angle that is 1/8 the measure of angle H? Go ahead and hit pause, jot down your thoughts, hit play when you're ready to check your work. So coming back to my picture, I would have to bisect one of these guys, right? I cut it in half, I've cut it into 1/4, and then I would have to again do an angle bisector one more time in here to create an 8, an angle that's an 8. So if you bisect one of the angles that's 1/4 of the measure of the original angle, you should get an angle that's 1/8 of the original angle. As always, guys, I hope you found this helpful. I hope you found this useful. If you got questions, concerns, come talk to me, and I'll see you guys soon. Bye.